Hello and welcome to my video, lesson 3.1, exploring probability. So what is probability? Probability is a measurement of the favorable outcomes versus the total outcomes in a situation or something occurring. So just to write that down in more of a formula, we can talk about it as probability is a fraction. We could also call it a decimal, because fractions and decimals are the same, but a fraction of the favorable outcomes, that means the ones that you want, versus the total. So the total is on the bottom of our fraction. Okay, so when we talk about something being fair, as in a fair game or a fair chance or whatever we want to call it, we mean that the odds are even, or they're the same for all outcomes. Okay, so if it's a fair game, that means the probability is even for every outcome. So flipping a coin to get heads, well, it's 1/2. So one of the two choices is heads, and there are two possible choices, so a total of 2. So 1/2. And tails is also 1/2. So tails is the same. So this is actually a fair thing. But if you roll a pair of dice to get to go for a 7 versus to get a 5, those are different odds. They're different probabilities. So to get a 7 is more likely. This is more likely than to get the 5. This is less likely. To get the exact amount, I believe it's something like 7 out of 36. But let me just think about that. So 1 and 6, 2 and 5, 3 and 4, and then, yeah. So no, it's got to be 6 out of 36. I think that's right. 6 out of 36. So then it'd be 4 and 3, 5 and 2, 6 and 1. Yeah. So 6 out of 36, so it's 1 in 6 chance, whereas a 5 is a 4 out of 36, so that is a 1 in 9 chance. So it's more likely to get a 7 than a 5, so it's not a fair game. So if the game was, if you roll a 7, you win, and if you roll a 5, the other person wins. Well, you have a better chance because you're going for a 7. Okay? So theoretical probability versus experimental probability. Mr. Drager was playing a nerdy game with his friends where the worst possible dice roll is to get a 1. So knowing that he was rolling a 20-sided dice, what's the theoretical probability of him getting a 1? Okay, so what we need to do is just think, well, if it's a 20-sided dice, and we're assuming that it's a fair dice, which it was. This is a true story. Well, at least the first part is true. Second part's only partially true. I don't remember exactly how many. It's 1 in 20. Okay, that's the probability. But in fact, Mr. Drager rolled 5 ones that day. I'm not sure if that's true. I did roll 3 ones in a row, which is actually even less likely. So we'll talk about that moving forward, but I actually got 1 in 20 times 1 in 20 times 1 in 20. So that's a fun and separate, and later on we'll talk about it. But anyways, I got 5, let's say I got 5 ones within 50 rolls. What was the experimental probability? Well, that's 1 in 10. So experimental probability is not necessarily what your odds are every time you roll the dice, but it's just whatever happened to occur that day. So usually experimental probability is close to, but not the same as theoretical probability. Could be a little bit more, could be a little bit less, but usually it's fairly close. But usually it's not the same either. So drawing from a deck of 52 regular playing cards, what is the theoretical probability of choosing an ace? I suggest you pause the video, try this out, and go from there. All right, so going from trying to draw some cards from a 52 regular playing card deck. Theoretical probability tells you there are 4 aces in the deck, 1 per suit, and there are 52 cards in the deck. So you should have a 1 in 13 chance of pulling up an ace. After drawing 7 cards from a certain hand, none are aces, 0. So 0 out of 7. So experimental probability tells you it's 0. So usually in our examples we'll have more than that, but could happen. All right, I hope this video helps you understand probability a little bit better, especially the meaning of the word fair, theoretical, and experimental probabilities in these examples. Hope this video helped, and good luck.